What's nice is quadratics is a topic that you are very familiar with. Okay? What I'd like you to do is, in your group, tell me how you know it's a quadratic by looking at the graph and by looking at the equation. You have 30 seconds. All right. Pod 6, graphically, what is it going to look like? Like a U. What do we call that U? A parabola. Pod 1, algebraically, what's it going to look like? Pod 1 is right here. Pod 1's right here. Caroline, Nicole, Ryan.
Well, we said that like when like the highest value is x squared.
Okay, our highest power is x squared. Okay, here we go. F of x equals ax squared plus bx plus c. This is a quadratic function. Okay, now something that's kind of strange in this book compared to last year. This is what you used to call standard form. This is no longer our standard form. Okay? Our standard form is more like what you would refer to as vertex form. And that's what we're going to write down on the next slide. Okay? So first of all, we recognize that we have a quadratic because we have x squared. Right? That's our highest power of x. Okay? When we write it in this form, this is going to be called standard form. And this is what you recognize as last year's vertex form. Okay? What?
Is that official, or is it just?
Well, when we get to the end of second semester and we talk about conic sections, then this is going to be more like what our standard form. We're going to adjust it a little bit, but I think it's kind of this book calls this standard form, and I'm not really sure why. Ms. Krunke and I discussed what we were going to call it, but to be in line with the book, we're going to call it standard form. If you call it vertex form, I'm okay with that. Okay? Why did you call this vertex form? All right. Gabe, say that louder.
HK.
HK is your vertex. This x minus h, that number is going to give you the x coordinate. This plus k, that's going to give you the y coordinate of your vertex. And with as many hands shot up along with Gabe's contribution, that's pretty familiar from last year. Okay. Also, I have this dotted line up here that's going through the vertex. What do we call that? The axis of symmetry. The axis of symmetry will always be the vertical line going through the vertex. All right. If A is positive, Henry, what does our parabola look like? Which way is it opening? It opens up. Okay. And here's our vertex. Flash back to chapter 1. What did we call this special point right here? where our graph switched from decreasing to increasing? What do we call that? Jackson, do you remember?
Call it the origin.
We do not call it the origin. Only 0, 0 gets called the origin. And it's not guaranteed that that's going to be there. What did we call that point where we switched from decreasing to increasing? It is a turning point. Darby, what's true about that point? Is there anything lower than that point? There is not. So we could call that a, Kelsey, say it. Yes, it is a minimum. Okay? We call them relative minimums. This is actually the absolute minimum because since it's a quadratic, we know it's not going to turn back around. Okay? If A is negative, with your arms, what does our parabola look like? Function aerobics time. Okay? So Connor, what is the vertex when we have an upside down parabola? It is a maximum. Okay? I will tell you right now, being able to identify the vertex is going to be very important in this section. And since it's something we've done before, I am going to ask you to do some word problems where you're going to have to identify a minimum or a maximum value. And that vertex is going to help you. Okay? There is a word problem in your homework that is bolded and underlined that I expect everybody to attempt tonight. Okay? Okay. Now, luckily, when we are in this form, it is super easy to graph, isn't it? Because we did all of that work with transformations. Okay? So, if a quadratic is not in our new standard form, we have to get it there. Please write this example down. We are going to go through a technique called completing the square. May ring a bell from last year. If you don't remember the name of it, it'll at least look familiar when we go through it. But after lunch, we're going to complete the square with this example and another example. This is going to be the meat and potatoes of your assignment. You have to know how to complete the square. Okay? Go to lunch, hustle back. You're hungry, right? Okay, so before we left for lunch, I had you write this example down. We need to get this into standard form so we can identify the vertex and everything else. And it's easier to graph that way. Okay, if we know where the vertex is and we know all the shifts and transformations, easy to graph, right? Okay, so let's recall how to complete the square. Okay. First thing, we can only complete the square if the leading coefficient is a positive 1. Is it a positive 1? Excellent. So we are good to go. So what we are going to do is we are going to add a number to create a perfect square trinomial. Okay? We're going to force it to be a perfect square trinomial. Now, is it okay to just add a number? No. If we add a number, what are some ways we can balance out the equation so we're not changing a value? One way, Jackson.
We can also subtract that same number on the same side.
We can subtract it from the same side. What would be another possibility? Add it to the other side. Okay? In this case, since we're reorganizing an equation, like we're not solving for anything, it's going to be in our best interest to add and subtract the same number, so it's like we're adding 0. Okay? So, let me remind you how we complete the square. This coefficient, you've already written it down, it's b. We're going to take b over 2, which would be what? which would be negative 3. And that squared, what is that squared? That is our mystery number. So this mystery number is b over 2 squared. Okay, that's how we get that. Is this ringing a bell from last year? Okay, good. So now, what's the point of that? Now we have x squared minus 6x plus 9. Well, what does that factor to? X minus 3 times x minus 3, which we can write as x minus 3, the quantity squared. And then we can combine those two to be minus 10. And there we have it in standard form. Okay. So let's talk through what we just did. We added and subtracted the same number. That way we didn't change the value of our equation. We took this number b, cut it in half, and then squared it to go here. By doing that, we created a trinomial that would factor to be a perfect square. So this factors to x minus 3 times x minus 3. So we write it like this. And then we combined our negative 1 and negative 9. Okay. That minus 3, does that look familiar from anywhere else in our work? It is a shift, but how about in our algebra up here? Does that negative 3 appear anywhere else? Okay, that will be a relationship. Okay, that b over 2 is always going to be that number that it factors to. Okay, whether you want to remember that or not. Okay, so now that we have it in standard form, Jackson mentioned, hey, there's a shift. What kind of shift is there? Right 3, down 10. This is going to be pretty easy to graph, right? Except I have to count a lot. Those little guys. Our graph took us about 10 seconds, okay? Because we know all of our shifts and transformations. Okay. Let's identify some things, because you will be asked to identify, like the vertex. Amanda, where's our vertex? 3, negative 10. Because we have a shift of right 3 and down 10, our vertex is now at 3, negative 10. AOS stands for axis of symmetry. Will, where's our axis of symmetry?
What's the vertex?
Okay. So how would you describe the equation of that line?
X equals 3.
X equals 3. Remember, it has to go through the x coordinate of our vertex. Well, it has to go through the vertex, so since it's a vertical line, we focus on the x coordinate. Do you have a question? No. Okay. What if I asked you to find zeros? How do you find zeros? Which one? You plug 0 in for x or y? Which one? Y, okay? When I say zeros, we're talking about where y is 0. If I say intercepts, Gabe, that is what you described to me. Plug 0 in for x, plug 0 in for y. Okay, but zeros specifically are talking about x-intercepts. You're going to have to do this in your homework, and I want to go through. If it's in this standard form, or vertex form is what you might like to call it, it's going to be very simple to find our x-intercepts. Plug 0 in for y. let's solve that equation. What should we do first? Add 10. Now we have the squared isolated, so how do we get rid of it? Square root both sides. Remember, when you square root both sides, we have to account for a positive or a negative answer. Okay? So our zeros are at 3 plus or minus square root of 10. Since it's a quadratic and we graphed it, we can see that it goes through the x-axis twice. We should get two values here. Okay? If you do the work to put it in that standard form, it's a two-step, three-step process to find your zeros. Okay? They don't always factor pretty. Obviously, that one doesn't factor. Okay, so this is going to make it easier. Okay, Mrs. Homan, what happens if our leading coefficient is not 1? How does that affect our completing the square? Let me warn you while you're writing this down. Since completing the square is something that you did last year, on a quiz or a test, your leading coefficient is probably not going to be 1. Okay? These are the examples that you need to focus on now that you are an honors for calculus. Okay? So, is our leading coefficient a positive 1? It is not, which means we need to factor out whatever that coefficient is. Okay? But I will give you a hint. Whatever this plus c value is, we don't have to worry about factoring that coefficient out of it. Okay? We're eventually going to need that plus k value. Do you agree? So what we can do is we can factor the leading coefficient out of the x squared and the x term and leave room for a mystery number. But if we close the parentheses, we can still keep this as a plus 7. That way we don't have to worry about factoring that 2 out of the 7. Okay? We know we're going to need a plus k, so let's just leave it outside of the parentheses. That way it's not affected by factoring out the 2. Okay? B over 2 would be what? 2. 4 over 2 is 2. We have to square it. So b over 2 squared, our mystery number is 4. Now, are we really adding 4 to our equation? What are we really adding? Well, we want to add nothing. I wrote a 4 in here. Is that really a 4 that I wrote? What? I wrote a 4, you see a 4, but that 4 is being multiplied to the 2, so we've really added 8 to our equation. So to balance it out, we need to subtract 8 from our equation. You see that? Okay. So what we have is 2, x squared plus 4x plus 4 factors to x plus 2 times x plus 2. And then we have 7 minus 8, which is minus 1. There's our standard form. Yes? No. Okay. Questions on the algebra? Marissa, where's our vertex? 2, -1. -2, -1. I was going to give you a chance to look at that. Okay, this is a shift left 2 and down 1, so our vertex moves to -2, -1. If we were to graph this, we have that vertical stretch, all right? So at -2, -1, our next two coordinates, instead of being right here, would stretch to double right there. Axis of symmetry. Tannen, where is it?
X is -2. X equals -2.
Thank you for correcting that to x equals -2. If you write -2, you will not get any credit. It has to be the line x equals -2. All right. Questions on the completing the square? We will do one more problem before you leave that involves completing the square, but first I want to look at this example right here. I am giving you two pieces of information about the graph. We know the vertex is -411, and we know that it passes through a point -615. Brainstorm for 30 seconds about how we might be able to solve this problem. Talk to your pod for 30 seconds. 1, 2, 3, go.
So put the 15 instead of like change everything to y equals x and then put y. That's what I'm saying.
Yeah.
All right, let's come back together. Tannen just said we can use that -6 and 15, plug -6 in for x, plug 15 in for y. Did anybody have that same conversation? Yes? Okay. Any other pieces of that conversation that you said?
So you could use the vertex of -4 and 11 to write the original equation in vertex form.
Okay, so we know the vertex as well, so we can write it in vertex form. Darby.
And then you need to find C, so you can solve it and get C, and then rewrite the equation of x equals y.
Okay, so you know what? I'm going to do one better so that you don't have to complete the square. All right? I would write it like this first. So you don't have to worry about that C value. I would automatically write it in standard form. Right? Our vertex is at -411. Does that match my work? Okay? Now, we don't know what A is, so most of you talked about, well, we can plug an X and Y value in. So we can plug 15 in for Y, -6 in for X, and now we can figure out what A is. Yeah? Did you grab the homework assignment?
Thank you, compliments.
So what's -6 plus 4, the quantity squared? 4. When we subtract 11 over, well, that sure works out nice, doesn't it? When we plug our x and y values in, A is 1. So our equation is y equals 1 times x plus 4, the quantity squared, plus 11. works out pretty nice for us. Okay. All right, so as promised, I have new gold sheets for you, so you don't have to write this down. One thing that I do want you to add, I missed getting an objective on here. If you could please turn to the 2.1 objectives and then just add in somehow identify minimum or maximum of quadratics. One. Yeah, so that is something that will be important for quiz and test, okay? Let me go ahead and stop my recording.